is going to be a hands-on lab for sound waves. And so we're going to be examining the intensity of sound waves as they travel through various materials, including plastic, metal, and wire, and yarn as well. And the intensity is the rate at which energy is transferred through a given area, and it can be used as a means of scientifically determining the loudness of a sound wave that's emitted from a particular object when it's struck. So sound travels best through dense objects where molecules are tightly packed, and so it will generally sound better and louder when it's going through solids than it will in liquids, and then even worse as gases. So we're going to begin. This is a metal hanger on a string, and so just striking it without having the sound waves pull through the string, it kind of has a clanky, dull sound. And so then when I put my fingers around the string and then I strike it this way and I listen, you can hear a fairly loud echo, like banging the lid of a pot or maybe a trash can or something like that. And so I'm take this off of here, and we're going to now try the same thing again with string and a metal spoon. And so when you hit it on its own, just like that, you hear just a sharp metallic sound. And so then I'm going to do the same way again with my fingers and hit it again. And when I put it in my ears, I do hear a loud humming noise, and it lasts for a few seconds. And then finally doing the same thing with a plastic spoon and the same string that I've used in the other ones, and just hitting it on its own, you just hear a pretty much dull sound. Doesn't really sound like much. And then when doing it and putting it in my ears, I don't hear any sound coming through the string from the plastic spoon. Now to start again with the hanger, we're going to try it with yarn this time instead of the string, and see what effect that might have on the traveling of the sound waves. And so when I hit the hanger with the yarn on it, fell off there, but let's see here real fast. Okay, to try that one more time. If you hit it with that and put it in your ears, you'll hear not as loud of a humming noise, but it lasts a little bit longer than the sound waves did when the hanger was attached to just the string. Now to use the same yarn with a metal spoon, we'll see what that does. It's still a fairly loud hum, but doesn't sound as loud as when using the string. And then finally for the same yarn with the plastic spoon, which didn't make any sound last time, still doesn't seem to make any sound this time either. So the plastic doesn't appear to be a very good conductor for the sound. And then I don't have the resources to do the third part of the experiment, which is to use a thin wire in place of the yarn or the string. However, using a basic understanding of the sound waves, I should be able to draw my conclusions. So when I look at the various loudness of the objects attached to the different materials, being the yarn, string, or the piece of wire, the sound was loudest when attached to would be loudest when attached to the wire, followed next by the string, and then followed by the yarn. And this is because the sound travels better through denser objects, where the molecules are more tightly located together, and so it's easier for the sound waves to pass through. And the wire is the densest of the materials, and then the string follows that, and then the yarn is the most loosely made and packed. And so then looking at the materials that I was striking on the counter, the metal spoon is denser than the other two objects, and so the sound was loudest when the metal spoon was struck. The metal hanger was louder than the plastic spoon because the plastic spoon is not very dense, which is why I didn't hear very many or any sounds traveling through the string to my ears when I struck that object. So harder sounds are also known to generate sharper and louder sounds that have more overtones. So basically, all in all, this proves the fact that sound waves do indeed travel faster and better to the ears when they are traveling through denser materials.